Yeah, good afternoon, viewers. Good afternoon, viewers. Good afternoon, my fans. You're welcome to today's edition of our lecture. We're still on fish farming. Previously, we discussed water management in fish farming, and we said that in our next lecture, that is our today's lecture, that we're going to look at the pH values of our various ponds in the night and in the day. What is the difference and the cause of the difference between the pH value of our pond in the night and in the day? Of course, we do know that there are two ways in which oxygen enters the water, enters into our pond. Though it is through a process of diffusion. There are two major ways through which oxygen enters into our pond. One is through diffusion from the atmospheric oxygen. Some percentage of oxygen in the content of the air from the atmosphere enters to the water, to our pond. Though it's a very slow process, but still that some percentage of oxygen from the atmosphere diffuse into the water, into the pond. It's part of the oxygen content of the pond, which our fishes use in their breeding. Then, because it's a slow process, a small quantity of air, small percentage of air is what enters the water for our fish to use to oxygenate the water for our fish to use for their breeding. Majority or large quantity of the oxygen content of our pond, of our water comes from photosynthesis by the phytoplankton. Remember, previously we discussed the four aspects of physical component of our pond. We discussed the dissolved clay particles suspended in the water that makes the water to look cloudy or muddy. Then we also discussed the phytoplankton, the microscopic plant. We also discussed the zooplankton, the microscopic animal. And finally, we also discuss other aspects. But what I want us to look at today is the major sources of oxygen that enters the water, which our fish breed. What sustains the life in our pond is the oxygen content, or the oxygen concentration, dissolved oxygen concentration content of the pond. So what we are looking at is how does this oxygen enters the water. I say that the first is through the diffusion from the atmosphere, call it atmospheric oxygen, then that enters the water. Then secondly is through photosynthesis. Remember, we have the presence of this phytoplankton, this microscopic green plant that makes our pond to look green. Because what causes that green is due to the chloroplast content of the phytoplanktons that contain chlorophyll, the greenish pigment that actually attract ultraviolet rays from sunlight through the process of photosynthesis and releases large quantity of oxygen. We are not here to discuss photosynthesis because we know that oxygen is not the only product of photosynthesis. The plant also synthesizes their food through that process, because after the photosynthesis, the large molecule of oxygen is produced. At the same time, the animal synthesizes its food. Through the process, large quantity of molecule of glucose is produced, which the animal will use and store excess in form of starch. But we are interested in the oxygen content of the product of the photosynthesis. That is what add large quantity of oxygen inside the pond, which will aerate or oxygenate the pond. make it fresh and sustain lives of our fishes and other aquatic animals. So why is the pH value of this our pond different from the day and the night? Let us look at the source, what we call hydrogen triazocarbonate 4, or the carbonic acid formation. During photosynthesis, we know during the process of photosynthesis, carbon dioxide is taken away from the environment for the reaction, photosynthetic reaction, and at the end of the day, oxygen is produced. So photosynthetic takes away carbon dioxide and then produce oxygen. So you see that in the daytime, because of the sun, the photosynthetic process will absorb most of the carbon dioxide content of the water. How is this carbon dioxide produced? Remember, the fishes in the water and other aquatic animals there undergo what we call respiration. Remember, in respiration, for we animals, for we living organisms, we take in oxygen and then produce carbon dioxide. Unlike photosynthetic process, which works in the opposite. Carbon in photosynthetic process, it takes in carbon dioxide, then produce oxygen. While during respiration, we living organisms, we take in oxygen and produce carbon dioxide. So this carbon dioxide content of the water is produced during respiration of the fishes and other aquatic animals. As they are undergoing respiration, they will be producing carbon dioxide that will be accumulated in the water. In the day, this carbon dioxide, when they are produced, they mix with the water and form what we call carbonic acid. Once they mix with water, they form what we call carbonic acid. Carbonic acid, the IUPAC name, that's the International Union of Pure and Applied Chemistry name of carbonic acid, is triazocarbonate 4 acid. The triazocarbonate 4 acid is actually what increases the acidity of the pond. It makes the pond to be acidic. What we say that by increasing the acidity is, you see that it lowers the pH value. Remember, pH value start from 7. When the value is 7, we say it is neutral. If it is above 7, which means it is climbing up, we say it is alkaline. But if it is below 7, we say it's going down, we say it is acidic. So when the pH value is below 7, we say it is going down. So the water becomes acidic. So in this case now, when there is an accumulation of carbon dioxide in the water as a result of respiration by the aquatic animals, including our fishes there, when this carbon dioxide accumulates, they will be reacting with water, forming what we call carbonic acid or triazocarbonate 4 acid. This will increase the acidity of the water. This takes place in the daytime because of the presence of the sunlight. Remember, photosynthetic process takes place only in the presence of the sunlight. So in the daytime, when the sun sets, photosynthesis will start taking place. As a result, in the process, it will start, as the photosynthesis is taking place, it will start taking all the carbon dioxide content of the water, thereby lowering the concentration, the carbon dioxide concentration, because the photosynthetic process takes this carbon dioxide. So as the day goes by, the reaction is taking place. This carbon dioxide will not be allowed to accumulate. There will not be an accumulation of this carbon dioxide because the photosynthetic process will be absorbing them. As the photosynthetic process is absorbing them, what happens is that it will not allow this carbon dioxide to accumulate, react with water and form acid. So in that case now, we say that the acidity, the pH value is increasing. The water becomes more alkaline because this carbon dioxide that will react with water to form carbonic acid is not allowed to accumulate because they are being taken off constantly by the photosynthetic process, like the photosynthesis. So they will not be allowed to accumulate. As a result, the water will tend to be alkaline, But in the night, when the sun has gone, when there is no sun, there will be no photosynthesis. there will be no photosynthetic reaction because the sun has gone down. As a result, the carbon dioxide begin to accumulate. As this carbon dioxide accumulates, they will be reacting with water, forming carbonic acid, thereby increasing the acidity of the water. So what am I saying? I'm saying that in the night, the water becomes more acidic in the night. In the daytime, it becomes more alkaline. It is obvious. The process I've just explained now why the water becomes more alkaline in the day, because carbon dioxide that have been produced through the respiration by the fish and other aquatic animals there will not be allowed to accumulate, because photosynthesis is taking place constantly, thereby absorbing them in the process and producing more oxygen. So as a result, the water tends to be alkaline. But in the night, when there is no sun, when the sun has gone down, there will be no photosynthetic process. As a result, the carbon dioxide will begin to accumulate and start reacting with water and forming carbonic acid and making the water to be more alkaline and to be more acidic. So this is the reason a successful fish farmer is one who must know all these things. A good fish farmer must know the differences in pH values of his pond, both in the night and in the day. When is it expected, water is expected to be acidic, when is it expected to be alkaline, is very important. Then having discussed the pH values, another factor we have to discuss is the oxygen content of the water. There will never be life in the water without oxygen, dissolved oxygen. We call it oxygen concentration. So anywhere you see a water that contains some live animals there, so that contains some excess of life there, it then means that there is large quantity of oxygen there. That is life sustenance. That must oxygen sustain life in the water. There will never be life in water without oxygen. So when you look at the performance, optimum performance of our fishes, you will now see that it depends largely on the oxygen concentration content of the water. Very, very important. So now, like I said before, how does oxygen get into the water? Remember what I said earlier, through diffusion from the atmospheric oxygen into the water, though that one is a very slow process. As a result, it's a very slow process, so it adds little quantity of oxygen into the water. The majority of oxygen concentration in the water comes from photosynthetic process of these phytoplanktons, this microscopic plant content of the water. That's what we're saying. So how do we measure this oxygen? A good fish farmer should know, just like you can always measure your pH value to know whether the water is acidic or alkaline. You also have to measure the quantity of dissolved oxygen or oxygen concentration, DO. I mean dissolved oxygen concentration, DCO. Dissolved oxygen dissolved oxygen concentration content of your pond, because that will determine the performance of your fishes. So how do we check this the quantity of oxygen in the water? One is that we buy a pH value, a pH scale or pH meter. You also use what we call oxygen meter. We have also an oxygen meter you will use to measure the values of the oxygen concentration, dissolved oxygen concentration in your pond. The value is what is most important. If the case, because there are different fishes. Different fishes require different oxygen concentration in the water. We are using Clarias gariepinus, that is African catfish, as our reference point. African catfish requires about 3 milligrams of oxygen per liter. 3 milligrams of oxygen per liter. So if you use your oximeter and to measure the